Hello, we are team number 12 and we are going to present you the final project delivery number 7 about logistic regression. To implement the logistic regression, we need to make some changes in the dataset. First, we read all the CSVs, the two CSVs, one from the CP and one from tool. Then we, in the tool CSV, we transform it, all the NAs in the dataset to 0, and where there's a tool, we change that to a 1, meaning that the tool is used in that stage. And with the CSV, we transform all the NAs into a zeros. Then we verify if there is a CP value corresponding from the data tool to the data CP to have a response value to fit in the model. We use in the line 25, we use that formula to find the values of lot in CP that are not used in tool. And then we find the lines with the line 27, the rows that are not present in tool CSV, and slice them from the CP dataset. Then we make the same to the tools that are not present in CP, and we also find the lines in the values that are not present in CP, then change that values to from lot name to the CP value given in the data of CP CSV to have response variable, the response value of CP from all the lots depending on the stages. Then we do a parameterization in the data to obtain values between 0 and 1 to make the logistic regression. We found the maximum value of CP, and all the data we divided into that maximum value, and it gave us values between 0 and 1. Then we, in the line 48, we can see the type of data that we are managing. Then the 949 tell us if the data has some NAs. It has to be 0 if there is no NAs present, and if there's 1, we have to clean all the data. In our case, we clean it well, so we have that value 0. The line 50 is the logistic regression. We use the CP as the response variable, and all the data and all the stages as the independent variables. We choose the binomial family. Then we got the logistic regression. We set the summary and then sort all the coefficients to have those coefficients that are the minimum values in one hand and the maximum values of coefficients in the other hand, to know what are the variables or the stages that affect the most the CP response value.
Once we have done the first logistic regression model, we can obtain the variables that affect the most negatively and the variables that affect the most positively. The ones that affect the most negatively are stage 45, 61, 56, 38, 43, 89, 94, 81, 90, and 8. The ones that affect the most positively are the stages 02, 40, 55, 68, 51, 58, 88, 31, 13, 57. With this, we can create a new model with a new data set, only taking into account the ones that affect the most, the 20 that affect the most, and we create a new regression model in the same way that we did the last one. We create a logistic regression model, and with this, we can create a prediction. With this prediction that we have here, we can create a chi-square analysis in order to analyze our residuals. So we use the observed value minus the response. This would be squared, and this would be over the response. The sum of all this will be the chi-square result, and we can see that here is 81. Comparing it to the ridge regression model, we can run the program. And with this, we can obtain almost it's similar results, because we can see that the selected values, the selected variables, sorry, are almost the same. It only varies on one of the ones that affect the most, that is the 0.17 instead of the 0.02. And the coefficients also vary. So we have that the same chi-square analysis with the sum of the observed minus the response squared over the response is 91. So we can see that the chi-square error is less in the logistic regression.
That's all. Thank you for your attention.